So in this in this video, we are going to talk about create ingress routing scenario from Kubernetes. It's going to start the course from here. Okay, so there are four steps. One step is creating the deployment. So as you can know, from this command we can create the deployment. So it says waiting for Kubernetes to start. Can deployment by email. It's still starting. Okay, so after that we just created deployment.yml, which is web app 1, web app 2, and web app 3, and web app 1 SVC, web app 2 SVC, and web app 3 SVC. So you can see the view, the status via here using this command. Then move to the second step, which is deploy ingress. So this from this command, we can see the load balancer service type from here. From this, as you can see, and the tasks. From this task, we have to do the ingress controllers are deployed with the familiar fashion up to the Kubernetes objects with kubectl create -f ingress.yml. That's command, and as you can see, engines ingress -rc was created here, and the status can be viewed using kubectl get rc. As you can see, the name and the when status are created. Move to the third step, which is deploy ingress rule. So from this command we can define the rules with it, and from this task we have to do all Kubernetes objects. They can be deployed via this command here. Web ingress created, and once deployed, the status of the all ingress rules can be discovered via kubectl get space ing. And this command here. Okay, so moving to the fourth step, which is final step. The first request will be processed with the web app 1 deployment test for the test purposes. You can see from here, and the second request will be processed with the web app 2, and so does the web app 3. So that you can see the hosts. All the requests were made by. That's all for the creating REST routing scenario. We will be moving to the scenario, which is use Kubernetes to manage secrets and passwords. Start the scenario here, which is 4 steps. First, we have to start the Kubernetes via this command. Still starting. So we have to create the base64 string and store them via the variables in this from this command using this command. So from here, so it says username echo admin base64 and password echo and this values and base64. So the secrets of defined by using YML below, we're using the variables defined above and providing them with friendly labels which applications can use. So this will create a collection of keys, values, secrets that can be accessed via the name. So in this case, test secret, we can run this command via here, the secret.yml, and we have to create the secret. So we are just by this command, we are just creating the secret, test secret. So we can define the commands we have using this code kubectl get secrets. It's already there. There's default token in this and the test secret. So I'm moving to the third step, which is consume via environment variable. So cat service env can use that. And to populate the environment variables, we define the name, and in this case, we secret username along with the name of the secrets collection and the key which contains the data. So in this task, we can launch pod using this command from here. As you can see, the environment pod was created. And once the process pod started, you output the populated environment variables from this command. And you can check the status of pod using via this command kubectl get pods. And moving to the fourth step, the final one, which is consume via volumes. So the use of environment variables for strong secrets in memory can result in them accidentally leaking. So the command, the recommended approach is to use mount them as a volume. So the pod specification can be viewed using cat secret pod.yml. This command here. To mount the secrets as volumes, we first define a volume with a well-known name, in this case secret volume, and provide it with our storage secret. So in this task, we have to create our own new pod using this command, which is called secret vault pod. So starts, once started, you can interact with the mounted secrets. So, for example, you can list all secrets available as if they are regulated data. So, for example, you can run this command and you can see the password usernames here. So, from this command, we can so this is not that one. Reading the files allows us to access the decoded secret value. To access the username we can use this. So we can see the username admin, and for the password, we read the password file from here. This was the password. That's all for the using Kubernetes, which is secret and password management. And next, we are moving to the liveness and readiness health checks. We're going to start the liveness and readiness health check scenario from here, which has three steps. From step one, we are going to launch cluster via this command. Which move to the second step, which is readiness prod, which is when deploy the cluster, two pods were also deployed to demonstrate health checking. So you can view the deployment with cat deploy.ym. So when deploying the replication container, each pod has a readiness and liveness check. So each check has the following format to perform a health check over HTTP. So you can see the format from here. To get the status, we have to run this command. You can see the status of the brand front for a MPG, and to find out more details of why it's failing, describe the pod. You can use this command. As you can see its status. So once our second pod readiness okay, then we have to return an OK status on launch. So we are using this command to do that, and going to the third step is final liveness prop. So as present, no crash should have occurred. So it's running this command to do the details of that. And to crash the service, HTTP server has additional endpoint that will cause it to run 500 errors. So using kubectl X, it's possible to call the endpoint this command. So as you can see, So liveness. So based on the configuration, Kubernetes will execute the liveness probe. So if the probe fails, Kubernetes will restore and recreate the failed container. So execute the above command to crash the service and watch Kubernetes will commit to run. So we just did it from here. So you can see unhealthy. So this command to check take a few minutes to detect. So this is zero restarts. So that's all for the liveness and readiness. I'm moving to the another scenario is deploy Docker compose file compose. So to start the scenario here, which has 6 steps. So first we have to install compose, deploy as a binary into a client. To install compose from category, we have to run this command. Okay. Now then we're going to install it from here. In steps 2 we have to do example files with Docker for the dashboard, sorry. So we can compose up use a single command from here. Says successfully the deployment. This master slave and front end. So the details of what has been deployed can be discovered within the Kubernetes CLI kubectl. So we can see from this command, as you can see the names front end. So moving to the third step, which is Compose also has the ability to take existing Compose files and generate the real Kubernetes manifest file. So in convert step, we are using this command to generate files. So yeah, as we can see the files, all the files from directory. So yeah, go to the fourth step, which is kubectl create. So we have to use this to create this kubectl contents and slaves and this YAMLs, and all things has been created now. Move on to the fifth step, which is OpenShift. So Compose also support different Kubernetes distributions, for example, OpenShift. So to do that, we have run this command. You can see OpenShift file solving has been created. Moving to the sixth step, which is the final one, convert to JSON. So by default, Compose generate YAML files, and it's possible to generate JSON-based files and specifying the -j parameter. So we have to run this command to see that through -j parameter. As you can see, it also has been converted to JSON.json format. Thank you, and we will be moving to the next scenario, which is deploying from source onto Kubernetes. Distance scenario here. It has 6 steps, which is the container. We have to run this command to cd web app hello, the Docker files also. So in this tutorial, we are going to use the Docker as our container format. So we created a simple application in Python, hello web app. We just created that. And to package the web app as a Docker container, we created a Docker file. We just created that also. So you can be the Docker container manually with this command. So now this command still building. Yeah, moving to the second step, which is running your containerized service. So you have successfully encapsulated the web app and everything needed to run the web app in a container. So from this operating system, help Linux to runtime environment Python to the actual app hello. So let's run the container via from this command. So you can see. So to see the host, you can see the uptime and the hello one. So go to the third step, which is Kubernetes and manifest, and Why do you need Kubernetes? Like in short, Kubernetes take care of all details of running a container, which VM server to run the container on, making sure that container has the right amount of memory. So and CPU example, etc. So we have to run this code to create manifest file. So here we go service and move to the fourth step, the container registry. So in this tutorial, Canacode environments has provisions the personal Docker registry to store the built image. So set the URL for registry as an environment variable with the command. So from this command, we're going to execute this command here. And in order to push the Docker image to the registry, we need to create a tag for the Docker image that contains our Docker repository name. We have to run this command to do that here. And then we can push the image we just created to the Docker registry. That can be done by this command. As you can see, it's pushing. And in the fifth step, which is running the service in Kubernetes, we have to write execute this command to obtain the deployment.yml. And if you run this command, you'll see that your specified Docker repository is now the deployment.yml file. Let's see that. Yes, it's hello deployment. Hello member extensions. Okay, so we will be moving to the this command to create service running. You apply a command by here. You can see the service. So we can see the service running via this command. So you can see hello web app and Kubernetes. So accessing the cluster. So now we want to send an HTTP request to the service. For most Kubernetes services are not exposed to the internet, so for obvious reasons. So we need to be able to access service that are using in a cluster directly. So to do that, we are using this command here, and we are using this command to. And the service was deployed dynamic non-pod was assigned to the pod, so we can this can be accessed via this service. But I already did it out here. And to store that port assigned as a variable for the later user, we have to use this command. And we can now send HTTP request to the service. We can that from this command. As you can see, current first 01 port global and up. So you can see the final steps. Your service is now automating the deployment process. So your service is now on Kubernetes and you want to create a custom greeting. So let's change some of the source code for this command. We can change hello world to hello hacker news. So we have to Fog is an open source tool for deploying services on the Kubernetes, and it already does the automation and then some. So let's try using Fog to do this deployment. You set up the Fog by this command here. To set up Fog, then the URL and the registry. So you can see and enter the username for the registry in case root. Yes. From root for the password. Yeah, login successful. So, that is happening now. And the process will take few minutes. Like let's go the next 7 minutes. Like is the container, and we need to start up the new bot for cover. Let's get the bot status. Okay, it's running, and you can see this terminating. So we have to run this code to obtain our port and to deployment, and to check that port again, we have to run this command. So you can see so first part. for this long one. Thank you very much for watching. Um, that's all for the Kubernetes.